1.1 million Bitcoin, $75 billion, sitting in wallets that have never moved, never spent, untouched since 2009. The coins belong to Satoshi Nakamoto, the anonymous creator of Bitcoin, a ghost who vanished 15 years ago and left behind the largest fortune in cryptocurrency history. For years, the crypto world has watched those wallets, waiting, speculating. Is Satoshi dead? Alive? A person? A group? But now there is a new question. A question nobody expected. What if someone else gets to those coins first? In March 2026, Google published a paper that changed the timeline. Their quantum research team calculated that a machine with fewer than 500,000 physical qubits could break the encryption protecting Bitcoin. Previous estimates said 10 million qubits. Google just cut that number by 20, and here is why that matters for Satoshi's fortune. In the early days of Bitcoin, wallets worked differently. They used something called pay-to-public key addresses, P2PK. These addresses expose your public key directly on the blockchain. Forever visible, forever searchable. Modern wallets hide the public key until you spend, but Satoshi's wallets are from 2009. They are P2PK. The public keys have been sitting in plain sight for 15 years. A quantum computer powerful enough to run an attack would not need to guess which wallets to target. The targets are already marked. To understand why this is possible, you need to understand what actually protects Bitcoin. Not miners, not the blockchain, not decentralization. Math. Every Bitcoin wallet has two keys, a public key, which is your address, and a private key, which lets you spend. The entire system depends on one assumption. You cannot reverse engineer the private key from the public key. The math is simply too hard. For a normal computer, this is true. The computation required would take billions of years. But in 1994, a mathematician named Peter Shor published an algorithm that changed everything. Shor proved that a quantum computer could solve this exact type of problem exponentially faster than any classical machine. For 30 years, this was theoretical. Quantum computers were too fragile, too error-prone, nowhere near powerful enough. Then Google's Willow chip arrived. In December 2024, Google announced a quantum processor that performed a calculation in under 5 minutes. The same calculation would take the fastest classical supercomputer 10 septillion years. Willow has only 105 qubits, still far from 500,000, but it demonstrated something the field had been chasing for decades: error correction that improves as the system scales. Previous quantum computers got worse as they grew larger. More qubits meant more errors. More errors meant useless results. Willow showed that errors could decrease as the system expanded. That breakthrough changed when, not whether. Google's own research now estimates a 10% chance of Q-Day by 2032. Q-Day, the moment a quantum computer can break current encryption. And when that day arrives, Satoshi's wallets become the largest visible target in financial history. But it is not just Satoshi. Roughly 1.7 million Bitcoin sits in old P2PK addresses. Another 4 million Bitcoin is in addresses where the public key was exposed through previous transactions. Total exposure: nearly 7 million Bitcoin, worth over $400 billion at current prices. And here's where the story becomes a civil war. Brian Armstrong, CEO of Coinbase, announced in April 2026 that he would personally oversee a new industry coalition. Mission: make Bitcoin quantum resistant before the window closes. Coinbase committed $150 million to a quantum defense fund. They formed an advisory board including cryptographers from Stanford and MIT. They began testing dual signature systems that could enable gradual migration. Armstrong called the threat urgent. Solvable, but urgent. Not everyone agreed. Samson Mow, founder of Jan3 and a prominent Bitcoin advocate, warned that rushing post-quantum cryptography could be worse than waiting. The new signatures would be 10 to 125 times larger than current ones. Transaction capacity would plummet. Compatibility issues would multiply. Mo said a poorly timed transition could weaken Bitcoin against today's threats before addressing tomorrow's. And then there is Adam Back, CEO of Blockstream, one of the original cypherpunks, the man whose work Satoshi cited in the Bitcoin white paper. Back rejected calls to freeze the vulnerable coins, to lock them until owners could migrate to quantum-safe addresses. His response was blunt. Quote, "You will be rugged anyway." His logic: if a quantum computer appears and steals those coins, that is a market event, not a decision for developers. Any attempt to decide which coins are valid and which are not is itself a rug pull, a violation of Bitcoin's core principle, immutability. The idea that no one, not even a majority, can change the rules to touch your coins. Back said the cure would be worse than the disease. This is the conflict at the heart of the quantum threat. On one side, pragmatists who want to act now. Upgrade the system. Accept coordination. Save the network. On the other side, purists who believe that changing the rules, even to protect people, destroys what makes Bitcoin valuable. Neither side is wrong. If Bitcoin moves too slowly, a quantum attack could drain hundreds of billions in hours. Confidence would collapse. If Bitcoin moves too aggressively, it proves that a small group can rewrite the rules. That immutability was always a negotiable promise. Both paths break something, and the clock does not care about ideology. But here is what almost nobody talks about. Bitcoin is just the canary. The same elliptic curve cryptography protects your bank, your medical records, your email, military communications, power grids. When NIST finalized the first post-quantum cryptography standards in August 2024, it was not for crypto bros. It was because governments know what is coming. Everything encrypted before the transition becomes readable. Every secret, every password, every file marked confidential. Adversaries are already harvesting encrypted data today, storing it, waiting for the machines that can open it. The strategy has a name: harvest now, decrypt later. Bitcoin just makes the countdown visible because its ledger is public, its rules are explicit, and its most valuable wallets have been exposed since day one. Satoshi's coins are not special because they belong to Satoshi. They are special because they are a timer, a measure of how much time the world has before the math that protects everything stops working. If those coins ever move, it means one of two things. Either Satoshi is alive and has decided to act, or someone else got there first. And the lock that protects the global vault has been broken. 500,000 qubits. That is not a prediction. That is an engineering target. And somewhere in Santa Barbara, in Zurich, in Shanghai, machines are getting closer every year. The countdown is not a metaphor. The countdown is real.